चलिए ठीक है, let's just 1 second. अच्छा कौन था? we're going to start with hydrolysis, ठीक है? So we're just going to try and do hydrolysis questions. इसमें था, let me just open the notes as well. What is hydrolysis? Okay, there's a part where where's A2? ठीक है, just 1 second. अच्छा, now in hydrolysis, say start maybe hydrolysis, ठीक है, just 1 second, after electrophilic substitution. The next thing is the strength of acids, bases, position of Cl. 1 second. हाँ, ये वाला part. ठीक है, let me just go through this once. नहीं, अभी questions इसके end में कर लेते हैं questions, ठीक है? Yeah, hydrolysis थोड़ा सा कर लेते हैं, then we'll do questions. चलो, hydrolysis of chlorinated compounds, ठीक है? Remember there are 3 compounds which are chlorinated, ठीक है? You've got chlorobenzene, and you've got halogenoalkanes, and you've got आपका जो एक सेकंड देना, अच्छा 3 chlorine related compounds, 3 of them. Chlorobenzene, halogenoalkane, and you've got acyl chlorides, ठीक है? 3 of them. No hydrolysis, medium moderate hydrolysis, you need NaOH aqueous and reflux. This one is vigorous reaction, vigorous hydrolysis, strong hydrolysis. It even reacts with cold water and forms fumes of HCl, ठीक है? So why is the first one not hydrolyzing? Because the Cl lone pairs and the benzene electron cloud, they overlap and they mix, and you've got a lot of electrons, so the bond becomes stronger, and the OH minus one, ये जो nucleophile that gets repelled. Negative ion gets repelled by the negative charge over here. Halogenoalkane have this more moderate hydrolysis, SN2, SN1 mechanisms. In primary halogenoalkanes, the OH minus one will get attracted to the carbon that's positive. Why is it positive? Because it's bonded to a Cl, which is electronegative, and the OH minus one is going to get attracted to it, and the OH minus one gets attached, and the Cl gets knocked out. So you have hydrolysis. And you've got an SN2 mechanism for tertiary halogenoalkanes, where what happens is that the Cl breaks off first, and after that it forms a carbocation, and then the OH minus one comes in. So you've got 2 types of hydrolysis for normal halogenoalkanes, and then for acyl chlorides you've got a very strong hydrolysis. The carbon is very strongly positive. Why? Because it's bonded to 2 very electronegative atoms. The water molecule is very strongly attracted to the partial positive carbon atom. So which is why it's a vigorous reaction, and you form fumes. It forms fumes of HCl. It even reacts with cold water. And you need to know the mechanism of the hydrolysis of acyl chlorides, which is known as an addition elimination reaction, where the first part is that the water molecule gets added to it, gets added to the carbon atom. The double bond electrons, they get repelled. Then the electrons come back, and the Cl gets knocked out. So that's the whole mechanism. If they're going to ask you to draw this mechanism, you're going to draw this mechanism. So we'll start with the questions, starting with the first one. I say all types of hydrolysis. It's about polymers as well. So over here he's saying when the nylon 6 monomer is hydrolyzed, bonds are broken and bonds are formed. So what is going to happen? And this is an acyl chloride. This thing over here is your acyl chloride. ये वही वाला है, ठीक है? Notes के अंदर it's this part that the acyl chlorides are going to vigorously hydrolyze. The water is going to be very strongly attracted to this carbon atom. So I'm going to do the hydrolysis of this thing. Just write, I'm going to take it as R, C double bond O, and Cl. They're not asking me for the mechanism, but I'm going to draw the mechanism anyways. This is slight negative, this is slight positive. The carbon is very strongly positive. So ये नीचे वाला Cl, that's also negative. So that's also negative. Now the first thing that happens is that the water molecule is going to get attracted. It's going to get attracted to the carbon that's positive. And the double bond electrons are going to get repelled. So the double bond electrons, they get repelled, they accumulate at the top, you get a -1 charge. The Cl at the moment is not doing anything, and the water gets attracted. And one of the lone pairs of water is now missing because it's gone to the carbon atom. So the water over here is now positively charged. What is the next step? That the oxygen electrons, they come back. The double bond is reformed, and this slight negative Cl takes away electrons from the bond over here. So the next thing that happens is the carbon forms the double bond back with oxygen. The Cl has knocked out, and your water is still attached, but it's positively charged. It's short of 1 electron. Okay, last step. Last step is that this Cl -1 comes back and steals the H from the water molecule. So the water H is positive. The Cl -1 comes in, gets attached to the positive H, and the positive H releases electrons, gives the electrons back to oxygen. So the oxygen lone pairs are reformed, and that's why you get a carboxylic acid. That's the whole substitution. So the question now is, when this molecule is, what happens to it when it's hydrolyzed? What happens? What bonds are broken and formed during the mechanism? He's talking about the mechanism. So the first thing is, over here at the top, a pi bond gets broken. So that's 1 pi bond. A pi bond, I'm just going to write 1 pi bond getting broken. And 1 sigma bond getting formed. You've got a single bond that's getting formed. So 1 pi bond is broken and 1 sigma bond is formed. Next step, the pi bond is reformed. So the pi bond is, sorry, नीचे sigma tha. Start में. In the second step, the double bond reforms. So that means the pi bond is getting formed back again. So that's 1. And the sigma bond over here is broken. So that basically leaves you with these 2 options, that both of them are getting broken and both of them are getting formed as well. ये clear है ये बात? Is this clear?
Sir, ये repeat कर देंगे.
ये देखो ना, उसका कि इस mechanism में ना, what are the total number of bonds being broken and formed? So first step, you have a pi bond being broken, right? Double bond turns into a single. Like अगले step पे, the pi bond is getting reformed. The oxygen double bond is getting formed back again. So pi bond got broken and pi bond got formed as well. ठीक है? तो ये clear है कि pi bond बना भी था, टूटा भी था. Is that clear?
Yes, sir.
अच्छा, फिर sigma bond got formed. ये oxygen formed a sigma bond with carbon over here. But a sigma bond got broken as well, right? The CCl bond got broken, right? So at the end of the day, it's both things are happening. Both pi bonds and sigma bonds are getting formed as well as getting broken as well. तो इसका ये आंसर होगा. This is the right one. इसको मिटा दो. Is that clear?
Yes, sir.
So next one, again, hydrolysis. Stan, explain the relative rates of hydrolysis. So this is your chloropenzene, this is your acyl chloride, and this is your normal halogenoalkane. So fastest कौन होगा? That's going to be acyl chloride. So this is your fastest hydrolysis. Or उसकी फिर reasons like, okay, why is it the fastest hydrolysis? Because the carbon carries a very strong positive charge. So carbon in RCOCl is bonded to 2 very electronegative atoms. And what are those atoms? Oxygen and Cl, which is why it has a strong partial positive charge and there's a strong attraction for water molecules, for nucleophiles. A strong attraction for water. The slowest will be chlorobenzene. No hydrolysis. उसके लिए आपने क्या लिखता है कि Cl lone pairs overlap with benzene pi electron cloud, and once they overlap, the CCl bond becomes strong. And it will repel nucleophiles, जो कि इस केस में water है, ठीक है? So it's going to repel the nucleophile. So it's the same thing जो यहाँ पे discuss की थी कि why is it a strong hydrolysis? The positive charge density is very strong, so very strong attraction for nucleophiles. What's wrong with chlorobenzene? Because the lone pair overlaps and the CCl bond becomes stronger, has a lot of negative charge density, so it repels any nucleophile that's approaching it. और बाकी भी वही है कि उस जगह saying explain the rate of hydrolysis of acyl chloride. You get a lot of these questions, ठीक है? Acyl chloride, alkyl chlorides, and aryl chlorides. So fastest will be aryl, the one with benzene. Slowest will be your fastest aryl नहीं है. Acyl is the fastest. Acyl chlorides will be the fastest. Aryl, the one with benzene, that will be the slowest. Or middle way, that's going to be alkyl, the ones with carbon chains. And you have to write the same explanation that the Cl lone pairs overlap with benzene. CCl bond charge density increases and it becomes strong and it repels any nucleophile. Acyl chloride, the carbon is bonded to two very electronegative atoms, and which gives it a very strong partial positive charge density, which is why it attracts nucleophiles very, very strongly. अच्छा, अगला पार्ट के अच्छा अगला पार्ट है chlorobenzene and chloroethane have different reactivities in nucleophilic substitution reactions. Identify a suitable reagent to illustrate the difference in reactivity. The reagent chosen should give visibly different results. So जब hydrolysis होता है, what happens? Cl ions get produced. If you have chlorobenzene, no hydrolysis will happen. But if you have an alkyl halogenoalkane, hydrolysis will happen. And that will result in the formation of Cl ions. So how do you visibly detect Cl ions? What you do is you add silver nitrate aqueous. So in this case, you're going to get a white precipitate. Okay? Every time the Cl is going to get substituted, you'll get a white precipitate of what? AgCl. Or chlorobenzene, when no hydrolysis will happen. So if you add silver nitrate aqueous over there, so the Cl is not going to get knocked out. So no hydrolysis, no visible result in this case. ठीक है, ये बात clear है?
Yes, sir.
So write an equation to describe any reactions that occur. तो वो दो equations होंगी. First thing will be that the halogenoalkane will react with when the water is react, it will hydrolyze a little bit. And what will be produced? The H and Cl, H plus 1, Cl minus 1 in the solution. And then with the Cl minus 1, and they will go and react with cellulines and they would form AgCl solid. Explain the difference in the reactivity of chlorobenzene and chloroethene. So वो फिर से वही explain करना है कि we basically उसको उठा के छाप दो कि chlorine has lone pairs, overlaps with benzene, charge density increases, repels any nucleophile, ठीक है. Whereas halogenoalkanes, they don't. अच्छा, अगला part. Cyclohexylamine reacts with ethanol chloride to form corresponding amide L. So, what's the name of the mechanism? So ethanol chloride is this thing. It's CH3, C double bond O, and Cl. Now, just now OH था उसी तरह NH2 भी है, and it has lone pairs, right? The carbon is positive. So acyl chlorides only have one mechanism, which is nucleophilic addition elimination. You get the same one that we just talked about. Acyl chlorides, and they have this mechanism, strong hydrolysis. The water ka lone pair gets attracted to it. So the other, anything that's got lone pairs, that will get attracted to it. And that is exactly what's happening over here. Although this reaction is not in your course, but that is iske andar exactly वही हो रहा है. So water का lone pair था, N lone pair will get attracted to the carbon. So it's addition elimination. The Cl will get knocked out. Okay? First step will be that double bond electrons are going to go away. But it's kind of the same mechanism. Okay? The N is getting attached to the carbon. और यहाँ पे he's asking you to draw this mechanism. ठीक है, तो यहाँ पे draw कर लेते हैं. So carbon is positive. This is slight negative. This is slight negative. The N lone pairs are going to get attracted to the carbon. What's the next step? Well, oxygen electrons, they get repelled. We've got a Cl. और वो जो R NH2 है ना, that has gotten attached. इसको बोल के H. But this N is going to get a positive charge because its lone pairs went away from it. It went to the carbon. Next step is the oxygen electrons are going to come back. And the slight negative Cl is going to take away electrons. तो वो फिर product बन जाएगा. ठीक है, your product will be what? CH3. C double bond O will get reformed. Your Cl minus 1 will, and the N over here will, नीचे bottom पे the NH2 will be bonded to it. There's going to be a next step as well, which is that Cl minus 1 will come back and take away one of the H's. लेकिन वो बाद में होगा. As a reaction between cyclohexylamine and an excess of CH3Cl forms. ये clear है वाला? Is this part clear?
Yes, sir.
The reaction between most people get confused with hydrolysis. You can remember to practice this a lot. The reaction between cyclohexylamine and an excess of CH3COCl forms compound M. Compound M has the molecular formula of this thing. Suggest and draw the structure of M. So वो कह रहा है कि now you've got an excess of CH3COCl. So what will happen if you have an excess of CH3COCl? The one thing, तो अभी हमारा एक CH3COCl के साथ you got this product, right? This is the product that you are forming. So what is the product? It's basically this thing. It's NH with double bond O over here and a CH3. Now, can this molecule react further? It still has a lone pair. So if I add another CH3COCl, the carbon is positive, and you can still get the same nucleophilic addition elimination. So the same thing will repeat, that previously you had an N, it got attracted to the carbon atom and it bonded to it. So the N still has a lone pair, so it's going to still get attracted to the carbon atom, and it can still form another product over here. So the product of this reaction will be you have an N which is bonded to serial bond ON CH3, and you have another N which is, and that N is again bonded to serial bond ON and CH3, but that's CH3 CO C10. So 6, 2 carbons over here, 2 over here, that's 10 carbons. H's kitne hain? That's 2 over here, 2 over here. So ये सारे H's हैं. That's I think 10. कितने H's हुए? That's अच्छा एक H यहाँ पे होगा. हाँ ठीक है, that's 17 H. So you're getting the same thing. You're getting the same compound over here. ये भी clear है?
सर
हाँ जी.
सर लेकिन N के पास लोन पेयर कैसे?
अच्छा वो वापस आ जाता है इनके पास लोन पे. वो शुरू में ये क्लियर था ना, पहले N का लोन पे चला गया था ना, it went away, right?
जी.
और फिर the oxidal bond was formed. N में ना what happens is that the Cl-1 comes back, ठीक है? The N still has a missing lone pair, ठीक है? So what happens is जो last step नहीं है वो Cl-1 comes back. Cl-1 takes away the H जो कि positive होता है, it forms HCl, right? और H जो होता है ना अपने इलेक्ट्रॉन वापस दे देता है. So N lone pairs they come back. यहाँ पे भी show हुआ है ना कि वो Cl-1 breaks off, but then the Cl-1 comes back, steals the H, and the oxygen gets the lone pair back again. तो lone pair वापस आ जाता है इनमें. ठीक है, is this clear?
Yes sir.
That's the next one, again hydrolysis. So it's the same mechanism. ठीक है. Carbon is positive. Remember 4 marks का, ठीक है? तो remember addition elimination, ठीक है? So O-1 Cl है, and then the water gets attracted at the bottom, but water has now 1 lone pair and it's positively charged. Our next step is the Cl takes away the electrons from the oxygen, they come back. So name the type of mechanism. That's nucleophilic addition elimination. ठीक है, that's the name.
सर
हाँ जी.
सर इस क्वेश्चन में भी उस तरह हो सकता है जिस तरह हमने पिछले वाले में किया, अगर एक्सेस में ले तो.
मैं देखता हूँ what is the product that you're getting. The product that you're getting is के डबल बॉन्ड O दोबारा आके और नीचे OH हो जाएगा ना. नहीं, इस केस में नहीं होगा क्योंकि अब ये कार्बन जो है ना, दिस इज नॉट वेरी स्ट्रांगली पॉजिटिव. OH का जो इफेक्ट होता है ना, दैट्स स्लाइटली इलेक्ट्रॉन डोनेटिंग. So now it's not going to attract carboxylic acid बनता है, the reaction stops. समझ आइए बात?
सर ऊपर वाला कंपेयर करके दिखा दें.
ऊपर वाले में जो हो रहा था ना, ये वाला ऊपर वाले में OH नहीं आया था ना. कहाँ पे? हाँ, तो the N still had a lone pair, right? तो वो N जाके acyl chloride तो वही था ना, it was the same acyl chloride. It was a reaction of acyl chloride with the lone pair of N. Is that clear?
मतलब OH के पास लोन पेयर नहीं है, इस वजह से नहीं हो सकता.
नहीं, क्योंकि अब acyl chloride ही खत्म हो गया ना. रिएक्शन क्यों हो रहा था? रिएक्शन हो रहा था कि carbon was very strongly positive, but now it's no longer strongly positive.
ठीक है.
वो उधर क्यों रिएक्शन होता है? तो कार्बन एसिल क्लोराइड, अगर इफ यू ऐड एक्स्ट्रा एसिल क्लोराइड, the carbon is still very strongly positive, so it will attract the lone pairs.
मतलब एसएल क्लोराइड के साथ रिएक्शन हो रहा था.
हाँ, तो nucleophilic addition elimination happens with acyl chloride. ठीक है. अच्छा, this one is exactly the same. कौन सा रिएक्ट करेगा, ये वाला या ये वाला? लेफ्ट राइट, which one? Acyl chloride is the one. हाँ, लेफ्ट वाला. ठीक है. So the N lone pairs are going to get attracted to it. The electrons are going to get repelled. Slight negative, slight negative. Next step will be that O minus one. The Cl. The N has bonded. But it no longer has a lone pair, so it's positive. And then you have a CH2 and Cl. The oxygen electrons, they come back, form the double bond. The Cl electrons, they leave. So the carbon double bond O gets reformed. The NH with two H's, AR CH2Cl. And the Cl minus one over here has broken away. And this N is positive. So Cl minus one वापस आएगा. It's going to steal one of the H's here from the product. Now, he says that this reacts with Y in reaction number 2. पता नहीं कौन सा 2 है? This is a different question. So the question is, why can it act as a nucleophile? The reason it can act as a nucleophile is that it's got a lone pair. It has a lone pair which can be attracted to positive charge.
सर ये वाला और ऊपर वाला सेम है, एसाइल क्लोराइड वाला.
क्या सेम है?
ये वाला मतलब एक्सेस में ये रिएक्ट करेगा एसाइल क्लोराइड की तरह.
ये
जी सर.
नहीं करेगा ना, क्योंकि एसिल क्लोराइड ही खत्म हो गया. आप कह रहे हो कि ये जो प्रोडक्ट बना है, विल दिस रिएक्ट? ये कह रहे हो ना?
जी.
तो एसिल क्लोराइड के अंदर रिएक्शन तो एसिल क्लोराइड का था ना.
ठीक है.
Acyl chloride, you need a very strong carbon positive. This is not a strong carbon positive.
सर लाइक इसका लोन पेयर भी तो वापस आ जाएगा ना, क्योंकि यहाँ पे नाइट्रोजन है.
हाँ, इसका वापस आ जाएगा ना, वो एक चला जाएगा ना.
तो फिर जब इसका आएगा तो फिर ये रिएक्ट नहीं करेगा क्या?
HCl बन जाएगा, इसका पॉजिटिव चार्ज खत्म, लोन पेयर इज बैक, राइट?
हाँ, तो अब दोबारा ये रिएक्ट करेगा क्या अगर हम एक्सेस
किसके
में
साथ
डालें?
करेगा रिएक्ट?
अगर हम ArNH2 अगर हम एक्सेस में डालें,
अगर तो हम एसाइल क्लोराइड डालेंगे फिर रिएक्ट करेगा.
ठीक है.
ठीक है, मतलब इसका लोन पेयर ना, दिस विल कम एंड गेट अट्रैक्टेड, तो यू नीड एन एसाइल क्लोराइड. ठीक है
सर आप इसको करके दिखा सकते हैं?
कि दोबारा रिएक्ट करके.
जी.
तो वही है, मैं इसके ऊपर शो कर देता हूँ कि सेम थिंग वुड हैपन, कि लोन पेयर वापस आया ना. हाँ, अब अगर एसाइल क्लोराइड डाले ना, एसाइल क्लोराइड इज द वन दैट रिएक्ट्स. कार्बन हैज अ वेरी स्ट्रांग पॉजिटिव चार्ज, सो this lone pair over here is going to get attracted to the carbon that's positive. So ये जो चीज है, this will go and join with this N again. जैसे पहले भी ये हुआ था ना, N went and joined with this. This N will come in and join with this. Is that clear?
Yes sir.
So ठीक है, वो that's hydrolysis. So we can move to acids and bases. And what's a weak base? कि base क्या होता है? It's a proton acceptor. What's weak? That it is partially ionized or weakly ionized. Partly, need partially. As a molecule of this thing contains two nitrogen atoms, both of which can act as a base. It reacts with HCl, complete the structure to suggest the product formed in this reaction. Okay, both of them can act as a base. So what happens when to complete this structure, क्या होगा structure के अंदर? You've got इधर एक H extra add हो जाएगा, and it will become positively charged, and there's going to be an H that will be added over here as well, and this one would also become positively charged at this point. So it reacts with H. That's it. ठीक है, that और तो कुछ नहीं होगा. वो है भी 1 mark. That's why ठीक है. So not much to this question. Acha, most acidic, least acidic. Who's the least acidic out of all these three? वो खत्म हो गया, हाइड्रोलिसिस खत्म हो गया.
3-chloro-propanoic. 3-chloro.
नहीं, 3-chloro नहीं होगा. अच्छा, let me discuss के comparison of weak acids, right? First thing is के the weakest one is an alcohol, not really acidic. Phenols are slightly more acidic. They would react with sodium, and they would also react with strong bases. और फिर जो तीसरा ना carboxylic acid, that is very acidic, ठीक है? So it will react with everything: sodium, strong base, weak base, another weak base, ठीक है? It will react with all of them and form salts, ठीक है? तो इधर वो carboxylic acid की बात कर रहा है. So we're going to straight away jump to carboxylic acids. Why are they such good acids? Reason they're such good acids is that when the H gets ionized, like as shown over here, तो क्या होता है? The oxygen over here has a negative charge, but that negative charge, it's got another oxygen which has a very strong electron withdrawing effect. So that negative charge gets pulled towards the other oxygen. So the negative charge density becomes very, very small, which is why it no longer attracts or bonds to the H+1 that strongly. So that's why it's easier for the H+1 to ionize. So a highly electronegative oxygen in C double bond O has a strong electron withdrawing effect, which decreases the negative charge density on the ion, making it stable and less attraction for H+1, or you can say that the OH bond strength decreases, which leads to more dissociation. Okay? So everything depends on this negative charge. The smaller it is, the less attraction for H+1, and the greater the ionization for H+1. So यहाँ पे, first thing, carboxylic acid strengths, they get affected by alkyl chain lengths. Alkyl chains are electron donating. If you've got two carboxylic acids, one has a bigger alkyl chain, it's electron donating. So what that does is it increases the negative charge density over here. If it becomes larger, it's going to be more attracted to H+1, so it will become a weaker acid. It's not going to ionize that much. So large electron donating effect, bigger alkyl chains, that would result in a weaker acid. Then you've got Cl substituted carboxylic acid. Cl always has an electron withdrawing effect. So if you put a Cl over here, the Cl electron withdrawing effect will make the carboxylate group less negative. Electrons are going to be withdrawn. And if it's lesser, it's going to ionize more. It's not going to be attracted to H+1. If there's more Cl, number of Cl ज़्यादा कर दो, if there's more Cl, the negative charge would be even lesser and the H+1 attraction would be even lesser. So there's going to be even more dissociation. Take the number of Cls, ठीक है? More Cls, stronger acid. और दूसरा ये कि Cl की position भी matter करती है, ठीक है? If the Cl is like really close to the carboxylate group, there's stronger electron withdrawing effect. So the negative charge would be smaller and the acid will be stronger. If the Cl is like really far away, then the electron withdrawing effect would be very, very less. So उस case में ना, the H+1 would not be that strongly attracted. So ये question इसके ऊपर है, position of Cl, right? So you've got three acids. One is so you've got three carboxylic acids. Let's say they're ionizing. So one is 2-chloropropanoic acid. So you got a Cl over here. The other one is 3-chloropropanoic acid. So double bond O. 3-chloro का मतलब है Cl is over here. ठीक है, the rest are H atoms. And then there's one with no Cl. So in Salome, which one has the stronger electron withdrawing effect?
Two-chloro.
कौन सा? ये वाला
2
है,
वाला.
ठीक है. Cl is like really close to it, so there's long, so this is going to be very small. So this would be the strongest acid. More ionization. ठीक है, the H+1 is not going to be that attracted to it. Weakest कौन सा होगा?
Propanoic acid.
ठीक है, वो alkyl chain है, तो the negative charge would be large, so it would be very strongly attracted to H+1, so that's why it's going to be the weakest acid. और इसको words में लिख दो, ठीक है, वो लिखा हुआ है सारा. तो बस यहाँ पे बताना Cl is like close to the carboxylate group RCO-1, more electron withdrawing effect, so charge density is lower, more stable, OH bond is weaker, so it's the strongest acid. Alkyl chains have electron donating effect, so which push, so the carboxylate acid has a large negative charge density. The OH bond strength increases, the ion becomes unstable, and which is why it's the weakest acid. अच्छा, bases में भी वही होता है, ठीक है. So you got these bases. Now you have the same thing happening with bases as well. The comparison of weak bases. Bases में ये होता है कि amides are not basic at all. You've got phenylamine that's slightly basic, ammonia, then you've got alkylamine that's strongly basic. अच्छा, why are amides not basic? अच्छा, bases में क्या होता है कि they have to accept an H+1. So electron donating group will make it a stronger base. जितना ज़्यादा negative charge होगा ना, the stronger will be the attraction between H+1 and the lone pair. तो यहाँ पे amides are not basic because वो जो साथ serial bond वो होता है, it pulls the electron density towards itself, which is why you don't have lone pairs to begin with over here. So it's not going to attract any H+1. Phenylamines where the lone pairs slightly mixed with the benzene electron cloud. So the lone pairs are partially there. So they're not, so the charge density is lower, but so they're not strongly attracted to H+1. So they're weakly basic. Alkylamines where you've got an electron donating effect. So the lone pairs have a higher charge density, which leads to stronger attraction for H+1. तो अब इसको basically करना है, तो ये पहला वाला S, not basic, ठीक है. A phenylamine is going to be in the middle, and you've got alkylamine, so that's a U. और उसकी फिर रीजन भी लिख लो कि यहाँ पे इलेक्ट्रॉन, मतलब वो लिखा हुआ वहां पे सारा जो हमने डिस्कस किया था, ठीक है. इज दिस पार्ट क्लियर?
Yes, sir.
चलो ठीक है. अच्छा, ये क्वेश्चंस बता दो. क्वेश्चंस है ये पे कल ही कंटिन्यू करते हैं. क्वेश्चंस बता दो कौन से पेपर में क्वेश्चंस है कि नहीं है.
Sir, October, November 2021.
2021. अच्छा, इस पे कौन सा वेरिएंट कौन सा?
Sir, question number 2, part B.
नहीं, वेरिएंट कौन सा? 41, 42, 43 कौन सा?
Variant
ये आवाज है. 4 कौन सा?
जी sir.
वेरिएंट कौन सा? 4 कौन सा?
42.
और क्वेश्चन कौन सा? 4.
Question number 2.
पूरा?
Part B.
अच्छा, a second experiment is performed and the value of KPC is found to be 0.670. ठीक है, KPC is given. The concentration of ethoxy, अच्छा पहले तो वो देखो कि प्रॉब्लम क्या है कि ethoxy ethane, right? Ethoxy ethane is the solvent and दो layers है, octane 1-ol and water. So as an octane 1-ol in water. So you got 2 layers. So you got a water layer and you've got an octane 1-ol. और उसके अंदर ना बीच में there's ethoxy ethane that's mixed. So some of the ethoxy ethane will be in the octane 1-ol layer, some of it will be in the water layer. So the question is, a second experiment is found, and the KPC value is found to be the concentration of ethoxy ethane in the octane 1-ol layer is 7.62. So KPC क्या होता है? It's gram per cm cube, यानी concentration in the octane 1-ol layer, और नीचे water layer है. It's the ratio of the solubility, right? तो ऊपर टॉप पे octane 1-ol, नीचे water. तो सब कुछ तो दिया हुआ है. It's he gave you KPC value. KPC value is given as what? 6.760 is equal to octane 1-ol की concentration is given. That's 7.62 gram per dm cube. In cm cube, what would that be in cm cube? Divide by 1000. So 7.62 बल्कि ग्राम पर dm cube में रहने देते हैं, ठीक है? 7.62 और नीचे जो है ना वो x होगा. To find out what this is.
1.13.
So 1.13 आ रहा है. लेकिन question clear है?
Yes.
अगला भी 100 cm cube octane 1-ol is shaken with 100 cm cube water. Calculate the maximum amount in moles of
मेरा आंसर 0.98 आ रहा था.
किधर? अच्छा वो नहीं 6.76 पर नहीं, मैंने कहाँ से दिया वो? नहीं वही है 7.6 and the value of KPC is found to be वो भी दिया हुआ है. Concentration of ethoxy ethane in octane 1 और तो नहीं आपका different आ रहा है.
जी सर मेरा डिफरेंट आ रहा था.
नहीं इसी का
मेरा 0.98 आ रहा था.
नहीं इसका क्या आ रहा है ये बताओ.
B1 का ना.
हाँ तो यही आएगा. नहीं कैलकुलेशन सामने है ना.
अच्छा
अगला calculate the maximum amount in moles of ethoxy that can be extracted into the water layer. तो अब ये कि maximum amount of so 100 cm cube, so you got two solutions now. So you got 100 cm cube of octane 1-ol. And you've got 100 cm cube of water.
सर ये वाला पार्ट हो गया था.
ये हो गया था. चलो ठीक है दूसरा बता दो कोई.
सर 3 का C इसी पेपर पर.
Sir, please पहले वो solve कर दें and then move on.
ऐसा वाला?
Yes.
ठीक है एक से. अच्छा 100 cm cube octane 1-ol layer and 100 cm cube water. उससे octane 1-ol layer की density ethoxy ethene octane 1 the concentrate second experiment the value of KPC is found to be this. So I'm assuming the octane 1-ol layer is at the moment 7.62 gram per dm cube. So 100 cm cube में क्या होगा? That's going to be 0.762 grams. But 1000 cm cube it's 7.62 grams. So in 100 cm cube it's going to be 0.762, right? ये clear है?
Yes.
So if it is shaken with water, a certain amount is going to go into water. ठीक है, let's say that's x gram. पीछे कितना रह जाएगा? 0.762 minus x, right? So you got the KPC value, which is 6.760. So octane 1-ol layer क्या? That's 0.762 minus x divided by 100. और नीचे क्या? That's x over 100. Water layer क्या? That's x over 100. The 100 part would eventually get cancelled out. So इसको आप solve करो तो it's going to be 6.760 x is equal to 0.762 minus x. Minus x को तो ले जाओ तो it's going to become plus x. So that's going to be 7. ये होगा ना math सीख रहे हो 7.760 x and that's 0.762. ये सीख है 6.
सर फर्स्ट वाला पार्ट तो उसके अंदर हमने 7.62 माइनस एक्स क्यों नहीं किया?
किस वाले में?
सर जो फर्स्ट वाला पार्ट है, पार्ट 1 B1.
इसमें
जी सर.
कि इसके अंदर वो कहता था कि it has already reached equilibrium. ठीक है, उससे बस कहा था कि अगर a second experiment is performed and the KPC was found and the concentration of the उसके अंदर 2 layers थी ना, तो उसने तो बस कहा था कि concentration निकालो दूसरी लेयर में. What's the concentration in the other layer? उसने तो he didn't give us the volume or anything. He didn't give us anything. ठीक है, तो वो तो हमने डायरेक्ट निकाल लिया ना concentration. Is that part clear?
ठीक है.
इधर अब वो स्पेसिफिक हो गए, वो concentration ही मांग रहे. He's asking for the concentration. मुझे पता है कि what is going to be the concentration. What he's wanting is the exact mass. तो हमें पता है कि if it's 0.762 grams, right? एक सेकंड देना.
सर लाइक जैसे हमने नीचे वाले पार्ट में भी सब्ट्रैक्ट किया है और अक्सर क्वेश्चंस में सब्ट्रैक्ट ही हो रहा होता है. इस क्वेश्चन में समझ नहीं आया कि क्यों नहीं हुआ.
सब्ट्रैक्ट हुआ है ना इसमें, क्यों नहीं हुआ?
लाइक सर जैसे 0.762 है माइनस एक्स है, जैसे इतने में से एक्सट्रैक्ट हुआ ना ये, तो ऊपर वाले में क्यों नहीं हुआ?
कि ऊपर वाले में मास निकालने को नहीं कह रहा था वो. एक्स मास है ना, तो ऊपर वाले में ही डिडंट आस्क फॉर द मास. उसने बस कहा था कि एक चीज है जो उसके अंदर वो एक्सट्रैक्ट नहीं हो रहा था. उसके अंदर वो था कि इट हैड ऑलरेडी रीच्ड इक्विलिब्रियम. और ये जो ये बना हुआ है ना, जो पिछला पार्ट था, उसके अंदर व्हाट ही वाज सेइंग वाज दैट इट हैड ऑलरेडी रीच्ड इक्विलिब्रियम. तो वो एक ऊपर कंसंट्रेशन हो गया, एक नीचे कंसंट्रेशन हो गया. सो यू हैव टू फाइंड द कंसंट्रेशन इन द लोअर वन. तो उसके अंदर कुछ चीज एक्सट्रैक्ट हो नहीं रही थी. ही डिडंट से कि he shook it with another layer or something. He just said that there was an equilibrium and there was KPC. You just have to find the concentration of the other layer. बात समझ आई?
जी सर.
वो यहाँ पे है कि इसको वो शेक कर रहा है with 100 cm cube of water. और वाटर के अंदर कुछ नहीं है, तो इसका मतलब है कि अब वो एक्सट्रैक्ट होगा ना, क्योंकि वाटर के अंदर इट्स प्योर वाटर, राइट? तो जब वाटर के अंदर डालोगे तो वो ऑब्वियसली उधर से नीचे आ जाएगा थोड़ा सा. ठीक है, तो यहाँ पे वो इशू आ रहा है कि सम ऑफ इट इज गोइंग टू गेट एक्सट्रैक्टेड, राइट? इज दैट क्लियर?
यस सर. यानी फर्स्ट वाले में दे हैव प्री मेड इक्विलिब्रियम पहले से रीच करा के उन्होंने फिर कंसंट्रेशन.
हाँ, मतलब जो उसको आप उसी तरह समझो ना कि पहले वाले में इक्विलिब्रियम जो है ना वो आई गेस पहले से ही प्रेजेंट है. वो केपीसी भी उसने उसी को कैलकुलेट किया हुआ उसने. ठीक है, तो क्या है इसका आंसर पे अगर मैथ सही है?
It's 0.098.
6.098.
0.098.
अच्छा ठीक है, 0.098. और ये दिस इज ग्राम्स, राइट? ही इज आस्किंग फॉर मोल्स. तो इथॉक्सी इथेन की एमआर से यू जस्ट डिवाइड एंड यू विल फाइंड मोल्स. ठीक है, तो अब चले जाए अगले क्वेश्चन पे कि अगला क्या है.
सर द क्वेश्चन नंबर 3 का सी पार्ट.
Calculate the quantity of charge in coulombs of the total number. पूरा ही करना पड़ेगा. ठीक है, he's saying pure water is a very poor conductor of electricity. However, when hydrogen chloride gas is dissolved in water, ions are formed and the current flows during electrolysis. ठीक है, so the overall charge after electrolysis is that the hydrogen chloride gas is converted into hydrogen and chlorine. When a current of 3.1 ampere is passed through the solution of Y, 351 cm3 of chlorine are produced at the anode measured under room conditions. Calculate the number of chlorine molecules produced. तो रूम कंडीशंस है ना, तो मोल्स निकाल लो कितने मोल्स है. पहले तो मोल्स निकाल, नंबर ऑफ क्लोरीन. हाउ डू यू कैलकुलेट मोल्स? मोल्स होगा 351 डिवाइडेड बाय 24,000. तो क्या आ रहा है? कितने मोल्स आए?
सर 8.8 into 10 power 21.
नहीं मोल्स पे, तो वो सारा इकट्ठा कर दिया, उसको सिर्फ एवोगाड्रोस कांस्टेंट से भी मल्टीप्लाई कर दो, ठीक
ये
है?
सर इसका आंसर.
मतलब मल्टीप्लाई दिस बाय एवोगाड्रोस कांस्टेंट व्हिच इज 6.02 times 10 power 23, तो कितना है 20, कितना है?
8.8 into 10 power 21.
3 सिग्निफिकेंट फिगर, तीसरा क्या है?
0.
चलो into 10 power 21. Acha, calculate the number of electrons transferred to produce the number of chlorine. So how do you produce a chlorine? Ke Cl minus 1 say you would have to lose 2 electrons, right? So the number of electrons will be double the number of chlorine molecules. So usko double kar lo, to what's the double of 8.8 into 10 power 21?
(1.76 into 10 raised to power 22).
I say number of electrons. Calculate the quantity of charge in coulombs of the total number of electrons. So 1 electron pe kya charge hota hai? That's 1.6 times 10 to the power minus 19 coulombs.
सर
हाँ,
सर इसी में पूछा था कि इसमें फ्रेडेस कांस्टेंट क्यों नहीं यूज हो रहा, लाइक 96500 जो हम यूज करते हैं.
इसमें
जी सर.
वो भी कर सकते हो, पहले तो इसका आंसर बताओ, इसका क्या है? फिर मैं वही चीज फैराडे कांस्टेंट के साथ भी सॉल्व.
28.6.
कितना?
28.6.
28.6?
16.
नहीं समझ आई क्या कह रहे हो.
सर 281.
2816?
जी सर.
अच्छा 2816 कूलम्स. चलो 2816 कूलम्स, ठीक है. सो अच्छा, इसको यू कैन डू इट विद फैराडे कांस्टेंट, लेकिन उसके लिए एक्स्ट्रा कैलकुलेशन करनी पड़ेगी बिकॉज फैराडे कांस्टेंट इज, it deals in moles. Okay, 1 mole of electron occupies how much charge? That's or carries it carries 96,500 coulombs, right? तो पहले फिर इन इलेक्ट्रॉन्स को मोल्स में कन्वर्ट करो ना, डिवाइड दिस बाय एवोगाड्रोस कांस्टेंट, फिर वो मोल्स के साथ रेशियो लगा के यूज फैराडे कांस्टेंट. इज दैट क्लियर?
जी सर. सर इसको करके देखिए.
तो बता दो ना क्या आ रहा है, इसके मोल्स कितने आ रहे हैं इलेक्ट्रॉन्स के, डिवाइड बाय द एवोगाड्रोस कांस्टेंट 6.02 times 10 to the power 23.
सर 0.02923.
कितना है?
0.02923.
0.292 कर लो. अच्छा ये आ गया, और रेशियो लगा लो एक्स, कितने कूलम्स होंगे, ऑलमोस्ट सेम ही आएगा.
2820.
बस ठीक है, वही है.
सर दोनों एक्सेप्टेबल होंगे.
हाँ, बस ये थोड़ा ज्यादा लंबा मेथड है कि वो जब डायरेक्ट आपको इलेक्ट्रॉन्स की बात कर रहा है तो आप उसको पहले मोल्स में कन्वर्ट करो, फिर यू कन्वर्ट इट इनटू.
सर यानी अगर हमें नंबर ऑफ इलेक्ट्रॉन्स गिवन होंगे तो हम उसका चार्ज यूज करेंगे, और
हाँ,
अगर हमें मोल्स गिवन होंगे तो हम
फैराडे कांस्टेंट. हाँ, बेसिकली फैराडे कांस्टेंट वही चीज है, बस फायदा ये है कि फैराडे कांस्टेंट इज ऑलरेडी कन्वर्टेड इनटू मोल्स. मतलब फैराडे कांस्टेंट डील्स इन मोल्स, ठीक है. 1 मोल ऑफ इलेक्ट्रॉन कैरीज दिस मच चार्ज, वो जो दूसरा दैट्स 1 इलेक्ट्रॉन कैरीज दिस मच चार्ज. तो मिनट से निकालो बी क्यू इज इक्वल टू IT, ठीक है. यू नो द चार्ज which is what 2816. और क्या पता था कि did you know the current? हाँ, the current was given, it was 3.1 amperes, ठीक है, that was given. तो निकालो टाइम, what's the time in seconds?
सर 908.38
अच्छा वो ये सेकंड्स है, ठीक है। इसको डिवाइड बाय 60 कर लो ताकि इट्स इन मिनट्स, ठीक है। तो you'll get that।
15
अच्छा और कौन सा क्वेश्चन है?
सर इसी का 6 का सी।
अच्छा case C, the numerical value for case tab of this thing is this. What deduction about the properties of CONH3 6 and COH2O6? अच्छा case tab, अगर वो इसका कहते हैं ना, case tab होता है क्या? It's the Ligand exchange reaction where you have this Ligand exchange reaction in aqueous solution, ठीक है, कि water है, cobalt in water 6, cobalt का charge क्या है? I think it's 2+. तो इसमें आप NH3 डालोगे 6 NH3s. So there's going to be a Ligand exchange and you're going to get cobalt with 6. The Ligand case tab was the ratio or the equilibrium constant of a Ligand exchange where a particular complex is in equilibrium with its aqueous solution, ठीक है। So +2 and the 6 water molecules get knocked out, right? ये reaction है, इसका case tab is this thing, ठीक है। case tab में aqueous solution से ना you form a particular complex. So the case tab value is this thing. ये बड़ी value छोटी value है? It's a large value, right?
Yes sir.
So case tab greater than 1 होता है, तो what does it mean? Okay, does it favor the products or does it favor the reactants?
I don't know.
Products.
Products like वो equilibrium constant होता है ना case tab. Product concentration divided by. तो अगर आपके पास product ज्यादा होगा तो you'll get a bigger value. So that means कि ये जो reaction है ना, it's shifted to the forward side. You get more products, ठीक है। So that means कि जो Ligand exchange है ना, that is happening. It's favored, ठीक है। Its product side is more favored. अगर तो backward होता ना, तो that means the Ligand exchange would not happen. So that means कि, so what does it tell you about the properties? के उसका मतलब है कि this is stable, easily formed, and this one is unstable. इसलिए वो नहीं बन रहा. But the reaction is favoring your products. Is ये clear बात?
जी सर।
तो और कुछ है इसमें?
नो सर, बस इतना ही है।
चलो ठीक है, चलो ठीक है, कल कंटिन्यू करते हैं, ठीक है।
ठीक है सर, अल्लाह हाफिज।
ओके, अल्लाह हाफिज।
Sir, what will we be doing tomorrow?
मैं ये कर लेंगे शुरू में कि वो उसको कंप्लीट कर लेंगे एसिड बेसिस, ठीक है।
Okay.
ओके, अल्लाह हाफिज।